more seamless. If you don't have real network connectivity, I urge you to keep your videos / cameras on. So the first talk or the presentation for the day is from Dr. Srikanth and co-authored by Divyashri and Arvind. They are from the Gayatri Vidya Parishad College of Engineering in Vijayapur. They will present their work on robot for delivery of medicines to patients using artificial intelligence in healthcare. So Dr. Srikanth, over to you. 12 minutes, all yours. Thank you.
Okay, Dr. Mishra, thank you very much. I hope my screen is visible and I'm loud and clear. So let me start my presentation on our paper and our work basically on a robot for delivery of medicines to patients using artificial intelligence in healthcare. So this was basically a tough challenge that we had to think and analyze because the current scenario, if we are taking robots in healthcare, okay, so there are so many parameters that we have to consider, like the predominantly safety of the patient and also the people who are handling the patient, like the nurses or the duty doctors and all, and the staff in such, and then current conditions like what we are seeing because of the COVID or any other scenario is making it difficult, and it is like we are having situations which are mostly dangerous and then very uncomfortable. So in those kind of scenarios, we felt, okay, maybe we can come up with something, okay, some prototype working to at least start with, okay, some fundamental work to deliver medicines and how we can do it was our thought, okay. And then for that we have used some literature, and we were having some robots in our campus. So like the Firebolt robot, which is the indigenous robot developed in India under the mentorship of IIT Mumbai. So that product as such we have with our lab. So we were able to analyze the situation, and we thought, okay, maybe we can design something and develop a prototype which can be scaled up. Okay, scaling up is a difficult task, but maybe we can initialize the idea because the program as such can be initiated. So this is like the picture that you are seeing here is a hospital scenario where we have a robot assistance in medical care. Okay, so ours as such is a very basic prototype model, which is like we were developing this robot medicine delivery system. So we have created like an arena. So in this arena, we were like identifying like a hospital bed, which is a COVID patient, non-COVID patient, or a vacant patient, like we have numbered. And then let us say this particular robot, which is called the Firebolt robot, was programmed, okay, in such a way that it will just traverse a particular path, and then it will try to deliver the medicine based on how we have programmed it. Okay, so there are so many assumptions that we have made, but because this is prototyping as such, first we have to see that our idea works first. So for that, the fundamental concept that we have taken was the valet parking theme that normally we have in literature exhaustively. So exhaustively we can find that robot valet parking is there in abroad countries. So maybe this concept can be pulled into medicine delivery, and then there are so many things we can use was our idea. So then we thought, what was the level of AI in which we have to work? Okay, so if we are familiar, okay, as most of the people are familiar, the 4 levels of programming in which we deal with AI. So thinking humanly or rationally, or acting humanly, acting rationally, or the different stages at which we can design robots. So our prototype model as such is a very basic mobile robot that we have used. So it is like how we think as a human, and then how we are trying to analyze the situation. And then we were doing like a pre-programmed method, okay, because it didn't have some of the features like the advanced dynamic changes in real time and all, but we were like sticking to the first level, basic level, because it is prototyping. And then so we have come up with this robot which will enter a ward arena. It will use some kind of sensors like the white line sensors and other infrared sensors that are already located on the robot. And then we traverse the given path, okay, and then identify the patient who is maybe a COVID patient or a non-COVID patient, and then it will wait 2 minutes or based on whether a particular patient was delivered the medicine, and then it will come back or exit that particular path and then complete its task. Okay, so it needed so many things that we were thinking when we were doing it. Okay, so not using a camera because we don't want to interfere with the privacy of the patients, because the robot might enter a wrong arena, or maybe it is as such people prefer that a camera is not mounted. So it is strictly based on a design which was using some basic sensors which doesn't use camera, and only IR sensors and the white line sensors and other sensors, such that it will take the medicine to a particular bed. It will wait 2 minutes or wait even longer. I'll showcase the situation, and then once the delivery of the medicine is done to the particular patient, the robot should know the closest exit and should come out. So that was how we have developed it. Okay, and then it is like there should be a LCD display on the robot and all. Okay, that can be used for the status of the medicine delivery. So that was what we have developed. So the program was pretty much easy because it was using the basic logic, but we had to develop, like I have shown, the test scenario and how to mark and how it will identify something like a pink identifier or a green identifier or the white block or a empty block. Okay, and then we were saying when it goes to the analysis part, so how does it identify the condition state of the patient, whether he was a COVID or a non-COVID patient, or it is a empty block, pink, green and empty. So different identifiers were used in the program. So it took us a little time for the program without using the camera to program this, but still we were successful. And then what was the difficult part was if we are trying to let us say extrapolate and scale it up. Okay, so this was whatever robot that we used was having a mobility at 30 centimeters per second. Okay, so it is a very slow robot that we have in our lab, but this is just a test bed. So we thought, okay, the test bed can be extrapolated, like how would a scenario if we extend this robot, okay, as such, if we extrapolate, what would happen? And then everything has to scale up, like the motor speeds and the capacity, that the battery life, everything has to be scaled up. So the provision as such, the payload of the robot doesn't have to increase very much, because the medicine as such do not weigh very much. It would be less than a few grams. So as such, that was the only difficult part that we were trying to understand was if we try to increase the length of the word. Let us say if we are traversing for 200 meters, or if we are trying to say there are some obstacles that are added. Okay, so because there is a scenario like something might come up in the path, because there is no camera and we are not watching the robot, how difficult it would be. Like the extrapolation was giving us more time, in the sense, let us say the robot goes to a patient location. Now the patient is asleep, and it is like we have to program the worst case. Okay, typically a person who is asleep in the morning or on the bed might awake only after 1 or 1.5 hours. So it is like 100 minutes approximately. So the robot should be programmed in such a way that it will ensure that it will wait. Okay, that amount of delay has to be there. Okay, a patient when a nurse, let us say, enters this ward, and has to wait for the patient to wake up. So waiting for 1 hour for the patient to wake up might be a difficult task for a particular human being, but that is not the case when we are taking the scenario of a person, I mean a robot in particular. So this wait can be used and the robot as such can stay in that particular position, and then we were like extrapolating all these kind of scenarios and trying to come up with some plan. Okay, and then we were also seeing like what would happen with the number of turns were increasing. Like let us say it has to deliver like 2 or more patients, and then how many turns will it has to take, and based on all this logistic analysis with the motion, we were seeing that the time as such was increasing. So the robot has to be scaled up. Okay, but as such, if we have to scale up the robot, it is a costly affair. So to prototype, at least we were thinking, okay, we can come up. We have come up with this idea of delivering the medicine in such a way. We write the program, and then we were able to do the ensure that it was reaching the target and completing the task. So as I was talking, I mean the major drawback of the system was in a dynamic environment. Okay, when the situation is changing, let us say a ward scenario changes normally, typically every maybe 1 week or 2 weeks. So if the program is written, and then how often we have to say change with the dynamics of the ward scenario is something that would have to be looked at, because this as such was like a static system that we have developed, and then we were using the AVR Studio. This basically was running with the help of USB SDK, which is a high-speed USB which is compatible for the AVR microcontrollers. And then we were identifying, like as I mentioned earlier, the pink spots and the green spots without using the camera, and then we were pretty much successful. But there are still a lot more to be done in this particular as such development. Okay, so the prototyping and scaling up involves a lot of cost, and as such when we have to do it in real time, it would involve many other bottlenecks. But in spite of that, we thought whatever we have done is a significant step in the design aspect as such, using some elementary level of artificial intelligence that we embedded into the program for this particular robot. And then these are some of our references. Basically, we were looking at papers on robot valet parking, and then we were also seeing some papers on the control strategies, how to how there are papers for delivery of medicine to tuberculosis patients already. And then there are some papers on artificial intelligence that we had to look at. And then there are these robots which work with wireless sensor networks, and then we worked on some aspects. We were studying about how we can use medical robotics, and all these aspects were some of the important things that we actually had to study in order to look at this particular development. So this is pretty much our work, basically how we have done this algorithm development, and then testing it in real time, and then projecting the values. Thank you very much.
Yeah, thank you, Dr. Srikanth. Any questions from the participants? You can post in the Q&A window. Well, while things are rolling on, let me get a few clarifications from you. So essentially, I understand the problem that you're trying to solve is you're trying to use a automated way of delivering medicines to patients, and that automation that you are achieving is through robots at this point in time. Now, see, I think there are a lot of assumptions that you have made here. Maybe these are some things that you will actually turn them into proper theses. But questions like how do you detect a COVID versus a non-COVID patient? That is not clear. Secondly, are you using this as an example to illustrate the case, or it could be any patient for that matter? If it's any patient, how do you detect the disease of that patient and appropriately figure out what medicine should go to that patient? or is it also pre-programmed saying that this bed number should get this medicine? Thirdly, detecting the patient's state or the disease that he has unobtrusively is a difficult task anyway. So what are the type of sensing mechanisms that you are thinking of using to do these things, right? You could probably say a couple of examples as to how you have achieved in probably your past examples or how you plan to do. So any comments on that, sir?
Okay, thank you, Dr. Mishra, for the question. First thing, regarding your first question, how we were identifying the COVID patient from the non-COVID, is like if you have seen the one of the slides I have projected, we were using these identifiers. Okay, so there was this pink identifier that would be placed in behind a particular COVID patient and a green under a non-COVID. So it is like, as I mentioned, privacy was the important aspect that we were thinking. Okay, so when we look at a particular problem, there are some assumptions that we have to make. I mean, based on the assumptions, we have to make some calculations and move on. So it is like we have put all these COVID patients with a pink color, and as such, as I've indicated, the medicine delivery would happen based on a pre-programmed code. Okay, so as such, like what is the bed number or what is the strategic location, after how many turns it has to take place, I mean, where it has to wait and where it has to be delivered. So I mean, coming to the other part, okay, so it is like as you have mentioned, the assumptions part. Okay, so as such, assumptions are something something that can be confined to one boundary. We keep adding things. Okay, it is like we have initially drafted like one arena. So we have built this arena, and then on this arena we thought, okay, let us say if we are taking this as a ward scenario, let us say we take 10 beds, okay, to start with, and if we want to deliver the medicine to the second bed, how we are able to do it, how much time we are taking, and what was the what are the drawbacks that we are having was the aspect that we were looking.
Okay, got it, Dr. Shrikant. So thank you for your clarification. So let's probably wrap your talk. Let's probably clap for you. We'll move on to the next speaker. Has the next speaker been made the panelist?
So paper A2 isn't.
So okay.
Shall we go to the next one?
This one is then from Nikhil Khare, right? Design and development of digital script. That's the paper, correct? Okay, 320. Okay, fine. Okay, Nikhil, are you ready? Why don't you share your screen and your slides?
Sir, is it?
Yes, it's visible. So let me just introduce you. So this paper is on the design and development of a digital scribe for visually challenged students. So it's presented by Nikhil Khare, and the other authors on this paper are O.M. Sharan and Manikandan J. They all are from the Crucible of Research Innovation Kori and Department EC in TS6 University. I typically I can see there's a lot of nice systems they have built for this, and I'm quite eager to listen to the presentation. So what do you take it? 2 minutes and take your questions. Thank you.
Thank you, sir. I would like to thank the Bangalore Section of IEEE for hosting the Humanitarian Technology Conference and for providing us with the opportunity to present the paper. I'll be starting off with the introduction. We did a research and found out that there are approximately 285 million visually impaired people in the world, and out of this, around 15 million reside in India. It is also common knowledge that exams play a huge role in Indian education system, and we put these two together to think about what happens to the visually impaired children in the country. In the current system, a scribe is assigned to each student, and when the visually impaired student dictates their answer, the scribe writes it down on a piece of paper. After extensive reading, we could come up with a few flaws in the system. There is an acute shortage of scribes available in the country. That is, the number of scribes to student ratio is low. Therefore, these scribes charge an exorbitant fee for their services. Second, there may be linguistic barriers even though the student has an excellent understanding of the subject. The student will find it difficult to communicate his answers to the scribe, while writing down by himself would have been more comfortable. We also need to consider human error in this. Spelling and grammatical mistakes are bound to happen due to mishearing of words or lack of adequate knowledge of the subject from the scribe's side. We on the next slide. We proceeded by researching the previous options provided to these visually impaired students. We already talked about the human scribes on the previous slide. To add to that, especially during and after the COVID-19 crisis, we expect the number of people who volunteer to scribe to reduce amidst the social distancing and other safety measures. And hence the prices will skyrocket, meaning the problem will escalate. The other option previously provided was the usage of JAWS and NVIDIA softwares, which would read the question to the examinee, and the student would have to use a braille keyboard to type their answer. This proved to be an expensive option as the institutions had to provide each student with an individual computer system and had to hire trained staff for teaching the students. The proposed work focuses on designing a digital scribe which can do the scribing part required for the student. The advantage is that they don't have to hire additional scribes. The teachers in the institutions themselves can dictate the questions to the students. Thus, many students can be assisted at once. A customer's Android application is already be open on a phone, and with the press of a button, the student can start speaking out the answer. The application is integrated with Google's speech-to-text API, which has a very high accuracy rate for recognizing the words uttered. The recognized words are then transmitted to the digital scribe file. There is a stepper motor on the other side which controls the y-axis. The stepper motor for x-axis is here. This servo motor is used to lift the pen up and down. This is the Bluetooth module. The ultrasonic sensors are used to detect the end of line and end of phase sequences. This here is a power supply of 12 volts 1.2 amperes. A similar source of smaller source of similar values can be used for commercial production. On the left, we have the prototype of the proposed digital scribe, and on the right, we have the circuit diagram for the same. These are the major components used in the proposed digital scribe. First, we have the Arduino microcontroller, which is used to control all the modules and sensors. Then we have the HC05 Bluetooth module, which is used to establish connectivity between the smartphone and the scriber. Then we have the NEMO 17 stepper motor, which is used to control the movement of the axis. To control these, we have the A498 stepper motor drivers. Then we have the SD90 microservo motor, which is used to lift the pen up and down. And finally, you have the HCSR for ultrasonic sensor, which is used to detect the end of line and end of phase sequences. Arduino integrated development environment is used to program the Arduino microcontroller to perform all the functionalities mentioned in the table. This slide shows a path to be followed by the x-axis motor, y-axis motor, and the pen holder to scribe uppercase letters, lowercase letters, numbers, and special characters. The dots in these slides represent the starting point of a stride, and the arrow mark represents the end point of a stride. The pen is lifted between the first end point of the first stride and the starting point of the next stride. As you can see, most of the characters can be drawn using a single stride. Only a few characters like capital K, X, Y, lowercase I, J, X, and special characters like percentage and question mark require more than one stride. Numerous experiments were carried out to calibrate the scribing system for preferred font size, which can easily be scaled to different font sizes. On this slide, we will be showing a demo of the proposed scribe. My partner is clicking the start speaking button on our app so that it can start recognizing the words. The uttered words are, I was blessed to have had loyal staff at United. The prototype is now scribing the uttered word sentence. I will be skipping a part of the video due to the time constraint. Our idea is still in the prototype phase, and of course, the final product can be made faster, cheaper, and more legible. To make sure that the scribe does not scribe the word full stop, we have used the keyword full stop to place a dot. So now here does some of them work for me for over 20 years. The experimental results seen in the slide indicate the individual words or text was satisfactory in terms of character shape and font size. The words had perfect amount of spacing between them. As in the images, the words were as legible as a handwritten sentence. Here, as you can see, are the words Sharan and Neelo, which are the names of my partner and his cousin. Here we have hi, how are you in neat legible writing. And finally, we have here enabling, spelled as ENABLING. On the top right, we have the customer's Android app called DigiScribe. The Bluetooth button displays all the nearby Bluetooth devices. The Bluetooth module is displayed here. When the Start Speaking button is pressed, Google Talk appears and the students can start speaking. The app was built using MIT App Connector. The functionalities of the app include recognizing the word spoken, performing speech-to-text conversion, establishing Bluetooth connection, and transmitting the text to the scribe by Bluetooth. The use of standard Google speech-to-text API with proposed app yielded satisfactory speech recognition accuracy for the proposed digital scribe. Design and development of a digital scribe for visually challenged students bridging technology and humanity is proposed in this paper. Since uttered words are recognized with 100% accuracy and the scribed words are as legible as handwritten text, the proposed digital scribe can be implemented without any second thought. Moreover, the proposed prototype can be commercialized at an affordable price of $20 for the basic variant. Here are some references and literature survey that we referred to. Thank you.
Hi, thanks, Nikhil. I think this is interesting work. Couple of quick questions. So what's your ground truth over here in terms of you scribe a letter A in a certain way using a system, but what is the golden benchmark for it? Have you benchmarked it across some standards that are used in the domain? Scribing.
Yeah, we'd like to have the best features for this, like in terms of character size and font shape. We would like to, for the final product, we'd like to have as many fonts as possible, like so that the user can select whichever he or she wants. Yeah.
So I think my specific question was, so is there some ground benchmarks for it, right? So for example, when you do experiments in some other domains, let's say you probably are trying to do a sensing application, right? Let's say noise sense. Let's say you want to probably sense the amount of noise in the air. So there's some benchmarking that this is a noise in a regular environment, and that's a noise when there's actually, let's say, something going wrong in a setting, right? some ground rules for it, right? So similarly in your application, when you're scribing A, do A in a certain way. So what is that percentage? How do you capture that matrix, accuracy matrix? If my A scribing is 60% accurate compared to this benchmark.
We refer to the normal fonts which are offered in Microsoft Word or other such applications, and we try to design it in such a way that the scribing happens in a very fast manner and very legible manner. Of course, there can be improvements made to this, and we'll always be trying to do that.
Oh, another related question, Nikhil. I like the thing that you are trying all these things with very simple systems here. You're using Arduino boards. I saw that the pen was mounted on a compass, right? So one of my lessons from my work has been that when you're doing such high precision jobs, we need to have very good equipment for it. Okay, equipment in the sense that essentially it's time precision control, right? Because every turn, every round you move, it has to be accurate time. That's what we call a scientific control. Now that all depends upon how accurate your clocks are in the system, how accurate your actuators in the system, and so on and so forth, right? So one of the things is that using Arduino is good. It makes the system low cost, but they are not the best platforms for doing such high precision control. Okay, so that is one observation that I have. Second is that when you're trying to use compasses to mount pencils, again from a high precision control point of view, they are not the best activity equipment. Okay, so one obvious thing is that if you use a little bit better hardware, you will by default better accuracy. But so that's one observation. Second is that even if you want to try with Arduino, try to at least use a better board which gives you a little bit better time precision control over there. Otherwise, what would happen is that you would spend a lot of effort trying to fine tune it, whereas you can just get away by getting better results by using a little bit better platform. Whenever your work is commendable, yeah.
Yes, since this is only in the prototype phase, we have used like whatever is available to us. If this goes into commercial production, we can think about having better materials used in this.
Okay, great. Thank you, Nikhil. Thank you very much.
Thank you.
So is the next speaker on board? Is it Vidisha?
Yeah. Can we start?
Okay, great. So Vidisha, why don't you set up your system? Let me introduce you to the participants meanwhile. So the next speaker is going to be Vidisha Bhatt and Muskan Mathur. The other co-authors on this work are Saifullah Samilla and J. Janita. The title of this work is Design and Development of Microcontroller-Based Writing Robot Using Speech Processing. So it's a good sequence because I think there will be some overlap in the scope of the work that the previous paper spoke about and this work. So let's see what are the new things we touch upon. Thank you. Over to you. 12 minutes.
Thank you so much. So what about the project? So it's design and development of writing robot using speech processing. Our paper ID is 360 and it is presented by Ms. Mathur, Satya Samra, Vidisha and Janita J. We are the students of AMC Engineering College. So I will start now. So what is the need of the proposal? As the name suggests, it falls into two domains, speech and robotics. So first let's talk about the need of the proposed system. So a lot of disabled students are facing difficulties in writing examination and the existing system of is quite outdated. So it will lead for the disabled students to drop out from schools. And according to a 2014 census, 40% of India's disabled population are still illiterate. This was completely before pre-COVID. Now during the pandemic, around 43 lakh disabled students across the country may drop out. This according to the census by CFAR. So this obviously increases the gap between education and students. So the main objective of our project is that we have developed a system which will help differently able students write their using the technique of speech processing and robotics. The system is interactive. This can be used in real-time applications. We even have the whole answer script made by the teacher. And we also have a hard copy and a soft copy. And the soft copy is actually printed by our robot, that is engraved by our machine. So go to our system design. So as our earlier project, I'll show you what's different in our project. So what happens before the examination, we put the question paper to our program. And that when as soon as the exam starts and the student sits in the system, you can hear the question. Like as if the number one question is what is capital of India, that the system will speak it out loud. And as soon as one question is done, the student can answer it. So as the question paper is being spoken out, there we have text-to-speech conversion. And as the student answers it, it becomes speech-to-text conversion. So that's completely different, and the whole goes on. Like we have the question through the microphone, question through the system, and the answer through the microphone by the students, and a whole iterative process goes on. And when it's done, it's this whole transcript is saved in a TXT document, and as soon as the exam is over, that TXT document through the SMTP server is made the teacher. That is already inputted. Like, before the exam, what email ID, all those prerequisites already inputted. And that is the soft copy part. And what to the hard copy, sometimes we do require the hard copy part. We are engraving to our robot. So what is happening there is text conversion, text to G code conversion is happening. Then that is given to our microcontroller. Again, we are using here audio, and that is attached to our CNC field that controls a motor, and that is given to our output. So there's a flowchart of the same thing of what's happening. And this part, what's happening, as that's not visible, but the user can hear the question, and when speak now appears, this is what the students put New Delhi, and we had given us 5 here. As you can see, this is the UI interface, and this is the unscripted mail to the teacher. It comes in this the question, answer. This is the TXT file which is received by the teacher when exam is done.
Next is the hardware setup. As you can see in the diagram, is run using BenBox software. The TXT file, as you have seen, will be inputted to the BenBox, and the BenBox, what it is doing, it is run the motors. You can see the diagram. There are two gantries, that is the X gantry and the Y gantry, which each moves in the X and Y direction respectively. Each gantry has a motor which is connected to the CNC sheet, acts as an interface between the Arduino and the motors. You can also see the stepper motor and the servo motor. The servo motor uses the spacing. Next is hardware output. This is a sample output which you can see in the diagram. Is the result the WER, that is the word error rate, is 21%, which is having a way in samples of various people have from age ranging from 15 to age 50, that is 50, and also people from the either genders. And also we can get different dialects. We can also use different microphones to get that 21%. And also the system, it can also detect different dialect synonyms, and also it can detect different languages. Next project where we can conclude by saying that this is an effective method of conducting an exam for the disabled. Instead of using the third describe, the present condition using the third party describe is very difficult. And this is much easier than conducting exams. And also this can be conducted for theory exams. Diagrams will be a lot difficult using this method. Next, in the future scope, there is a bright future as the world error can be reduced, and it can have better security. The mail which we have sent to the teacher, it can be password protected and encrypted. And then the hardware printing can be replaced with a high-end printer. Then just a prototype, and then the implementation of the diagrams can, and the input audio can be taken for a longer period of time. And also for hall ticket, we can use image recognition, fingerprint recognition, and iris detection as well. This was a big honor for us to present our paper. Thank you very much.
Yeah, thank you. I think you were in a hurry to finish your paper. But anyways, I think this is good work as well. I think you have built a platform and you're trying to propose a hypothesis and solve it here. Now, a couple of quick questions. Why is the error rate so high?
Oh yeah, this was before before we added the noise embedded function. This was like we were reducing sound was also coming, the surrounding one. After that, found that there was a noise embedded function, so that can be further reduced. So before that, we had already submitted the paper. So.
Okay. Now, in terms of your platform setup, what type of motor controllers did you use over there? In terms of, did you use a very dedicated motor controller, or you use some off-the-shelf platform like Arduino, which the previous author used that to control this? So, what were the details of the motor control?
We are using Arduino, and the motor controls are working through G code. We're using a benchmark software for that to like whatever text automatically convert the G code and then engrave it to the paper. Okay. In that case, I think the comments that not the comments, but the suggestions I had for the previous speaker also apply to you in terms of, as I said, for any of these high precision control works, I think you need a little bit better hardware. These are quite integrated and you need to be very efficient about it. So doing it with very low cost hardware whose clocks are really not that good means it creates more problems than solving. So I think that is something you can look at. But anyways, good work. Thank you. Any other questions for the chat? I don't see anything in the chat window till now. Okay. Anyways then, so we'll move on to the next speaker. We have Dr. Vijayapur with us.
Yes, sir.
Yes. So she will be presenting her work on harmonics at the API connected to nonlinear load power. So Dr. Vidya is a faculty member in, you pick up the college name, hold on.
Global Academy of Technology.
Sorry for so essentially, if you look at the paper, I think it's quite mathematical. I think from there we can see that she has very good skills in analytics and a lot of evaluations she has presented the paper. So I think without much let us hand over the podium to her. Madam, 12 minutes and 3 minutes for questions. Over to you.
Yes, sir. Thank you for the opportunity, sir. My student Pallavi is going to present. Later stage, I am going to take the questions, sir. Thank you very much.
Okay, thank you.
Yes, sir. Hello, good morning. My name is Pallavi. I am from Global Academy of Technology, Bangalore. So I am here to present our paper named Medication of Harmonics at the AC Mains Connected to Nonlinear Loads using Hybrid Power Filters under the guidance of Dr. Vijayapur, Professor in the Department of Electrical and Electronics Engineering at Global Academy of Technology from Bangalore. So in our paper, we are going to describe about modeling, analysis and mitigation of power quality problems caused by the nonlinear loads connected to supply. So we have to know that hybrid power filters can be developed using 1 or 2 or 3 passive and active filters, either to improve the performance or to reduce the cost of the system compared with active and single passive filters. So in order to reduce the cost and with the improved sensor technology, it is responsible for us to reduce the cost and improve the response of the hybrid power filters. So in this work, we are going to study the power quality problems caused by AC voltage controller with resistive load and also with the series RL load, which is connected with the nonlinear loads using MATLAB Simulink and proposed hybrid power filters to reduce the power quality problems. So the main objective of our paper is to reduce the several power quality issues of loads with nonlinear characteristics with the supply of the system on the basis of the consumer requirement. So here, in order to reduce the issues which is related to the quality of the power required for the smooth operation of the appliances used at the utilities, even when the power supply as the poor quality. So just to deal with the issues from the quality of the power, example, we are going to reduce some of the issues like when it comes to voltage based power quality problems, Here we can reduce the voltage harmonics, voltage fluctuations, and as well as sag with this well. So when it comes to current-based power quality issues, we are going to reduce the harmonic distortion of the current, reactive power, unbalanced current, neutral current, and the current fluctuations at the consumer end and also with the supply end. So here it provides the sinusoidal balanced current at the supply end with the DC bus voltage control in appropriate coordination with the series connected filter in a universal active filter as a combination of both two voltage source converters. So in order with the concern of the power quality related problems and oppression, so it is important to design the hybrid power filter to provide the harmonic compensation at the AC mains when it is connected to some critical nonlinear loads. So here comes the block diagram of our work. See, you can see here the AC mains, which is the supply and which is connected to the loads, nonlinear loads with some impedance. Here you can see the shunt passive filter, which is connected parallelly to the load, and this is the series active filter, which is connected before the shunt passive filter to the AC mains. So when it comes to the design of the filters, we have designed for RMS supply voltage with 230 volts with a frequency of 50 Hz with a resistor value 10 ohms and with the inductance 10 millihenry. So with the design of shunt passive filter, it is basically consists of a series combination of an inductor and a capacitance tuned to a particular frequency, and it acts as a low impedance path for that harmonic. So in the majority of the cases, these shunt passive filters have been considered more appropriate to reduce the harmonic current and partially to meet the reactive power requirement of these loads and to relieve the AC network from this problem, especially the current fed types of nonlinear loads, thyristor converters with constant DC load. When it comes to the series active filter, this is basically designed and also it is connected in the series with the AC mains before the passive shunt filter. This provides the harmonic and reactive power compensation resulting in UPF at the AC mains. So we have used the hybrid power filter in our work. It means that the combination of both series active filter and the passive shunt filter, we're gonna get the hybrid power filter. In this single phase active hybrid power filter, it consists of as I said, one branch passive shunt filter which acts as a high pass damped filter and a series active power filter connected in series with the AC supply. So as we all know, the main issue with these nonlinear loads is the harmonics. These harmonics are the results of the nonlinear loads, which gives the non-sinusoidal response to a sinusoidal signal. When we give the sinusoidal signal as the input, when it is connected to the nonlinear loads, we're gonna get the non-sinusoidal response that are called as harmonics. So in order to reduce those harmonics, we have connected the hybrid power filter. So here you can see the simulated module of circuit with hybrid power filter. This circuit is designed based on the MATLAB Simulink tool, and it consists of a supply connected to the nonlinear loads with R load. So here comes the waveform with hybrid power filter, and here you can see the first waveform is the input voltage waveform, which is the input signal, which is sinusoidal, and the second one is the input current waveform, and the third waveform is the load voltage waveform, and the fourth one is the load current waveform. See, in the second, third, and fourth waveforms, you can see the harmonics which are present. So in order to reduce these harmonics, we have used the shunt passive filter and the series active filter. So to reduce these harmonics, we have used this hybrid. With this combined, we call that as hybrid power filter. So finally, in the last waveform, sixth waveform, you can see the voltage of series active filter, which is sinusoidal. Here you can see no harmonics are present. So, okay, this is the written table of total harmonic distortion values. Here we have taken some of the inductance, resistance, and capacitance experimental based values like this parameter to know the value of the THD values of input current, load current, and load voltage. So, well, as we have performed this experiment, we have got without filter 29.15% of THD value for all input current, load current, and load voltage. When we have used only a single shunt passive filter with some desired parameter, we have got 29.51% of input current THD value and 29.15% for both load current and load voltage value. So when we use only a series active filter, we have got 4.87% of input current, load current, and load voltage THD values. So here we can observe that the harmonics has been reduced from 29 to 4.8%. So when we combine this both series active filter and the shunt passive filter, that is called as hybrid power filter, we have got 0.25% of input current THD and 1.27% of load current and low voltage THD. So finally, in our work, we have concluded that hybrid power filter is proposed to reduce the harmonics generated by the non-linear critical loads. So when we have done the analysis for this total harmonic distortion, it is considered one of the best performance studies in this harmonic. So finally, in our result, we can show that the non-linear load injects harmonics in the system, and the proposed hybrid power filter is the better solution for reducing the power quality problem. And this is also, it is a better alternative for reducing the harmonics and to improve the power quality. So due to its reduced cost with simple design and control with high reliability when we have compared to other alternatives which are available for power quality improvement. Thank you very much.
These are our references. So is there any question?
Yes, madam. Yes, Pooja. So, quick clarification. So, you mentioned that you can actually correct very poor power quality. So, how poor is it? So, what can you give me some numbers around it?
Yes, sir. When we are going to consider this analysis of power quality, we are going to measure that THD, threshold harmonic distortion. So, we are going to consider this THD according to IEEE standard. It should be less than 5%. When we are going to consider this harmonics, so we will consider that different order of harmonics. Actually, it should not present. So when we are going to consider this third harmonic, the frequency of the output will be 3 times the fundamental frequency. So actually, to get that fundamental frequency, we know that our AC supply in our India, the frequency of the AC supply is 50 Hertz. In foreign countries, we will consider it as 60 Hertz. So when we are going to get the output, the frequency should be 50 Hertz. Then only we will get that pure sine wave. So if it is distorted, we are not going to get that pure sine wave. Then this will affect the power quality issues, that is voltage sag, voltage swell, means that is a voltage fluctuations and frequency fluctuations. Then the power factor will also vary. To avoid that one, we have to eliminate these harmonics. So that's why we are going to connect the filters. Here we have tried with that shunt passive filter, series active filter, and then the hybrid filter. Actually, this project I had given to UG students because one of my PhD students is doing her research work on traction system. In that traction system, we are using most of the induction motors. Induction motors will create harmonics. That's why we have taken this R and L in series. R and L in series load represents the induction motor. So to study that one, we have done this work, and then later stage we are going to rig up the circuit by using these hardware components. So then we are going to conclude this.
So, madam, one quick question here. So, yes, this hybrid combination, so you have, it's a series combination, and if you first have a active followed by a passive filter, right? The shunt passive follows the active one.
Yes, sir.
What would happen if you basically interchange this order?
Actually, sir, when you are going to consider the shunt passive filter, there are its own advantage. Series factor filter, it is having own advantages. Some of the applications, only shunt active filter is enough. Otherwise, shunt passive filter is enough. For this application, we have taken both. So, as we elaborated here, this shunt passive filter and series active filter has their own advantages, sir. Depending on the load, we have to connect.
Okay. Now, I was specifically wanting to know, so your series connection has the series active first and then your passive shunt.
Usually what we will do circuits across the load, first we will connect. So we are trying to eliminate the harmonics with respect to load. So then if we are going to eliminate the harmonics with respect to load, so then we are going to observe that is there any distortion in the supply side. So if there is no distortion in the supply side, we are going to leave it. Or otherwise, we have to eliminate the harmonics during the supply side also.
Got it. Yeah, sure.
Yes.
Thank you.
Thank you very much, sir.
Thank you very much.
Thank you for the opportunity.
I hope your larger project of your thesis project goes very well.
Yeah, thank you very much, sir.
So we move on to the next paper presentation. So this work is on smart maximum demand controller for consumer loads. It is from BLDEA V.P.Dr.P.G.Halakatti College of Engineering, Vijayapur, and the presenter is Professor A.S. Melinamene. So over to you, madam. You have 12 minutes and 3 minutes for questions post that. Thank you. Madam, you can unmute yourself and project your slides. Ashwini, can you try unmuting Professor Melinamene?
Yes, sir.
Hello, madam. You can project your slides. We are all set. I think she dropped it.
Sir. What is first share of information?
Are you online?
Sir, I think they have left.
Yeah, I see them dropped out as well. So not sure what happened.
Yeah.
So this other paper we missed in the beginning.
Yes, sir. I'm making. Satish, sir, I'm not able to make you as a panelist. Can you read?
Mr. Satish, we are facing trouble in making the panelists. So try logging off and re-logging back. There's something wrong. I don't know. Hello, Satish.
Sir, I'm not able to make him as a panelist.
Yeah, so I don't know if he's able to hear us or not. He's muted, and Mr. Satish, if you are able to hear us, why don't you just ping us in the chat window so that we know that you are actually receiving or hearing us properly. Okay, Satish, okay, he is unmuted. Hello, can you hear us?
Sir, Anand, Melinamene, they have texted that they are not able to share the screen.
I see. Okay, in that case, if they're facing problems sharing the screen, please they can just speak about the work for the time being.
Anand, sir, can you check using your slides now? I have made you as a presenter.
Okay, Anand, can you hear us?
Yes, sir. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your slides now? I have made you as a presenter. Can you check using your s
There's a problem in his system. Something is not correct.
Anand sir, you have to allow audio options in your computer or laptop. Anand sir, we are able to see your slide. Can you check audio options?
Hello, is it audible, madam?
Yes sir.
Shall I
Yes
start?
sir, you're audible. Yeah.
Hello.
Yes, Professor Anand, you may begin.
Yes, sir. Good morning to all, sir. Myself, A.S. Milinmani, serving as assistant professor in A&D Engineering Department of BLDEA'S Engineering College. Today, I am going to represent our paper, Smart Maximum Demand Controller for Consumer Loads. So this paper mainly contains introduction, block diagram of Smart Maximum Demand Controller, consumer load control, electricity bill saving, results and conclusions, finally references. So in introduction, today we are observing that, sir, electricity becomes interposed in all sections of the human developments. So hence the progress of nation mainly depends upon the quality and quantity of electricity. But in developed countries, there is no problem. In developed countries, there is no problem. Where is side is sharing, sir? Sir, hello?
Professor Anand, yes, we cannot see your slide transitioning. It's still stuck on the intro slide. But nevertheless, I think you can go ahead and speak in that manner because you may be facing problems. We are listening you.
Yes, sir. There is a difference between developed countries and developing countries are distinguished by the quality and quantity of electricity, sir. So developed countries are having no such problem, but in developing countries, we are having electricity problems. There is a huge gap between generation and demand because vertical growth of population. There is more population problems are expecting in developing nations, sir. But Earlier, this gap was reduced by installing of new power plants. But now the technology changes. So we have to go for according with the changes in the technology also. Hence, one possibility is there. DSM technology we can implement. So we can implement the DSM technology either supply side or load side controls. So implementation of technology on supply side, it needs huge amount of investment and complexity process also, sir. But the implementation of DSM techniques on load side, it is economical and easier process also. And also we are considering the consumers into our national energy saving plan, sir. In this respect, IoT based smart demand maximum controller is an effort to control the consumer loads within their sanctioned load. If they are knowingly, unknowingly operates their load above the sanctioned load, they have to pay penalty charge in their electricity bill. Hence, if they are using this IoT based demand controller in their network, distribution network, they can relax it from the payment of penalty charge. So this block diagram, it shows smart maximum demand controller which works on the IoT base. So it has mainly three sections: power input and metering, maximum demand controller, and load controller units. So this consists energy meter. This energy meter is PPWK type energy meter. That means pulse per kilowatt energy consumption type. It is provides, or it is a specification of 2,400 to 3,200 pulses per kilowatt hour energy consumption. It gives the information to ESP toll transmitter. Hence, this transmitter counts number of pulses in 10 seconds. Then it supplies to the maximum demand controller. Then maximum demand controller, we have to make the programs as per the consumer's interest of the load profile. Load profile we have to develop in such a manner that total load should be operate less than their sanctioned load. For example, if the sanctioned load is 1 kilowatt, we can set a point either for 1 kilowatt or 0.9 kilowatt with the different possibilities of on and off conditions of the load. That is shown in load profile. That load profile is programmed. Then taking the input from energy meter, it operates always the loads less than their maximum load. If the maximum operation load occurs through the energy meter, then it will send the information to load controller through the ESP12 access point. This ESP12 load control receiver, it receives the information and sends the message to the relays through the shift registers. Then particular relays will control the on and off positions of the. Hence, in this manner, what is the set point in our microcontroller Raspberry Pi board that will allows as per the load profile. Hence, this demand controller controls always the load operation less than their sanctioned load. This is one typical daily load curve of the consumer. So, sir, it shows the daily load use of a typical consumer for 24 hours. Here we can observe his load was 1 kilowatt, but knowingly or unknowingly, he may operate his load above the 1 kilowatt. That what is the darker area? That is the penalty zone. So this zone is considered for penalty. This is for one-time occurrence. This is for one-time occurrence in a day or in a month. If number of times occurs during a month, then the fine amount becomes huge. If the same consumer, if the daily load curve of the same pattern, if we are implementing the smart demand maximum controller, then there is no possibility of existence because it controls 1 kilowatt only. It clips the penalty area. Hence, there is no possibility of penalty. So this is analyzed through the electricity billing system. Same consumer considered as 1 kilowatt his sanctioned load, maximum operating load. It is for 1.4 kilowatt. Excess of our demand is 0.4 kilowatt. He has to operate, maximum sanctioned load is 1 kilowatt. He has to operate his load always 1 kilowatt. But here he operates their total load 0.4 kilowatt is extra. This is for penalty consideration in electricity bill. Sir, I considered fixed charge per kilowatt rupees 60 and per unit charge 5 rupees 20 paise. Hence, penalty calculation depends upon excess. Then we have to consider total kilowatt hour or total units of that month. Then we have considered the ratio. We have considered the ratio of excess to total. Sir, 0.4 kilowatt is excess divided by maximum 1.4 into units of that 1 month. This is for excess energy consumed. Similarly, we are making the charge for fixed charge also, sir. So 1 kilowatt is there into 60 per kilowatt into 0.4. We are getting for this fixed charge also. So in this way, the penalty should be depending on fixed charge as well as their units. This is occurrence for one time. If the number of times repeated, then penalty amount goes on increasing. But on the other side, if same consumer is using of the maximum demand controller, then there is no question of penalty zone because the load profile is developed such that it should not cross 1 kilowatt. Similarly, we are having the options either 1 kilowatt, either we can set another points also, sir, 0.9 kilowatt or 0.8 kilowatt. Hence, in this manner, he can save his electricity bill. So, as per my explanation, my conclusion is that if the consumers are using this advanced software management tool in their distribution network, they are free from payment of penalty charge. Sir, if n number of consumers are implementing along with energy meter in their distribution network, hence we can save nearly 20% of national energy saving, and it also improves the load factor of the power plant, and finally it also improves power quality of the system. There is no problem of shutdown problems and 24 hours supply problems to consumers reduces. Once the load factor also improves, the cost per unit charge, that also reduces, sir. So finally it provides benefits to both sides, either consumers and supply authority. Consumers are relaxed from the payment of penalty charge. At the same time, the supply authority are relaxed from their postponement of new generation plants, sir. These are the references we have followed, but due to less space here for you, it is observed that earlier microcontroller things are developed and load operation is improper. Improper operation of load will affect on the grid performance. Slowly different technology have been developed. We have collected good surveys of paper, sir. Thank you, sir.
Thank you, Professor Anand. If I may request you to just go 2 or 3 slides back, I will probably use that slide as a backdrop to pose a question. Yeah, this one, sir. Yes, please. The next slide. Next slide.
This one.
No, the result slide. The box plot that you have. The result slide. Next one. This one, sir.
Sir.
So just the slide before this. Yes, consumer load control. Now, I have a very basic question here. So if you look at the left-hand side, you clearly show that yes, there's a sanctioned load of 1 kilowatt and somebody is overusing that, right? and by using your mechanism, you say that you have shaved off the peak from there. What I want to understand is, see, essentially when people are consuming over a capacity or consuming in a high way, there's a need for doing certain things, right? And if that need is not fulfilled at a time, they will defer that need to some other time. So essentially, it's more like, so essentially you are trying to spread the demand in time. Okay, at that, let's say that demand shot at 8 a.m., right? In a normal scenario. And if you try to suppress that demand at 8 a.m., that demand will show up sometimes later in the future. It may show up at 12 noon or 4 p.m. somewhere, right? Now, if that's how the behavioral model of users are. Now, if that's the pretext to that, then I would have seen that the plot, there would have been some difference in your plot in the around 4 in the later half of the day. But these two plots look identical. The only difference is that there is a overutilization at 8 a.m. and that's it. Apart from that, both the plots look similar. So what I'm saying is like the law of conservation energy. So if you have full conserved energy in some place, you will give out energy in some other place. That effect I'm not seeing in these results. So that's my basic question.
Yes, sir. Exactly. That is correct, sir. Some critical load conditions, some non-critical load conditions have to be identified and should be shifted, sir, some other day. It is not showing in second graph. That's right.
Okay. So just this was my observation. So please, if you believe that that is genuine, so please take a look at that as well. That's my only comment.
Yes, sir. Yes.
Thank you.
Thank you, sir.
So do we have the last speaker with us? Who Satish?
Yes, sir, but I'm not able to make him as a panelist. He said he's working on it. He's installing the app.
I see. So should we give
Satish, sir, you can. Sir?
Should we give Satish a few minutes?
Yes, sir. Satish, sir, you can rejoin through phone if it's if your laptop isn't working. Satish, sir, I can see you in the attendee list. Are you there? Sir, please join through phone.
Has anybody joined from the authors list? So Ashwarya, if it's not working out, I don't know if you should wait or not, because it's already been 10 minutes and I don't see anybody rejoining from their team. Are they communicating?
Yes, sir. Sir, I don't want to rejoin.
Okay.
We don't have his contact number, sir. We are not able to contact him. Hello? Sir, can we wait for 5 minutes?
Yes.
2 minutes. Yeah.
Prashant sir.
Yes, Aishwarya.
Sir, what do you want to do? I think we are not able to reach him.
Yes, already 20 minutes. I don't think they will join back. If they had to, they would have actually. So I think we can end the session.
Sure, sir. So please go ahead. Okay.
So I think there are just 5 attendees now. So thank you folks for joining the session. So as you can see, this was a session. This was a YP session on Humanitarian Technology. We covered a vast array of technologies, right from how can you use robots to actually ease operations and work for people who are challenged or people who need special assistance. We looked at the robots, how they can be used for automated delivery of medicines and so on and so forth. We also looked at problems of how can actually improve the power quality, as well as how can actually do good demand management using smart controllers and other things. So it cuts across domains of healthcare to smart homes and so on and so forth. So there are some interesting concepts that I have seen here. I hope that these concepts go ahead and actually mature in something useful, and that these papers then see the light of the day and they become demonstrable in some form and shape. So thank you folks for attending. Thanks to the volunteers, Aishwarya. I can also see Neha is on the call. So Neha was chairing or rather general chair for this particular YP track. So thanks Neha for organizing this, and thank you. We'll rejoin post that. Thank you. Bye bye.
Thank you, Prashant sir.
Thank you.
Thank you.
Yes, thank you. Thank you, Naman. Thank you, Prashant sir, for taking your time and being here for the session. It was great presenting here. And thanks to all the authors who had presented their papers. It was a great session. Thank you. Thank you, Naman. Thank you, Prashant sir.
Thank you. Bye.
Thank you. Aishwarya, you can end the.
Okay, ma'am.
You have to end the meeting.
Yeah. Ma'am, what about the recording session?
That will get saved.